Okay, doing another test with the same bit transformer as last time. I now have a 39.9 ohm resistor as the load. Before I had an 80.4 ohm resistor. I now have an 8 UF cap here in series from the primary of the bit to the shunt resistor, which is still a 1 ohm shunt resistor, but I'm going to put 0.1 ohm in tomorrow. So I just bought some. So, and then it goes to the other AC input from the grid. So that's the load, 39.9, and I have an 8 UF cap in series. And for square divisions on the scope, it's 0.2 volts. Okay. Now we're going to look at the output real quick. The sun's on it. Here's the output, 23.1 volts. Here's the output, 23.1 times 23.1 over 39.9 ohm resistors, 13.3 watts. Okay, that's what I'm getting out of this thing. Here's what the scope looks like. The amps is about 38 peak to peak. And the voltage is slope to the right and a kind of a pinpoint on top and a little slope below. Looks like it's kind of biased one way. And I have this on my computer screen. I took a photo so we can figure out the phase shift and the power factor. First of all, if it's 38 spaces peak to peak and we're in a 0.2 volt square division, that means every space is 0.04 volts. So here's the math. That gives you 1.52 volts divided by 2 is 0.76, and you times 0.707 to make RMS. It becomes 0.53 RMS, volts RMS, divided by 1, because I have a 1 ohm resistor, and it's 0.53 amps. And 0.53 amps times 122 volts coming in from the grid is 64.6 VA. And I'll tell you how many watts input right now, because again I'm over 90-degree phase shift, which I'll show in a bit. So I'm just saying it's 89 degrees, so it can be above the table, call it. So 64.6 times power factor of 0.017, which is the power factor for 89 degrees, is 1 watt, 1.09 watts. That's the input. And we know the output was 13.3. So we got about 13 times more this time than last time. Okay, let's look at the computer screen. Here it is on a computer screen, in a paint program. The AC cycle, let's just say from here to here, from there to there, one AC cycle is 12.2 spaces horizontal. The phase shift, you know, from here here, it's hard to do this, is 3.2 spaces. So I'm going to blow this up so you can look at it close. Okay, made it a little bigger here. Let's look at this one. That seems to me to be a little more than 3 spaces. So I'm saying 3.2. Here's another one of the phase shift. And the AC cycle is 12.2, a little bit more than 12 spaces. And let's blow it up one more time. Okay, it's blown up again. And let's just go from this point over to that point. That's one AC cycle. And you can see it's 12. And it's a little bit to the right there. And this is right on the line. So 12.2 is one AC cycle. Let's look at this one. It's a little bit to the right on that line. Just a hair to the right, and a little bit more to the right on this one. Let's look at that one. This one kind of, it's 3.2. See, the line to the left is a little bit not in the center, while the line to the right is right in the center. So I'm saying 3.2 spaces. Okay, so where I get the 0.017 power factor to put at the end of the volts times amps equation to find watts is 360 degrees divided by 12.2 is 29.5 degrees per space. And the phase shift is 3.2 spaces. So 3.2 times 29.5 is 94.4 degrees. So it's over 90 degrees. And again, to make it simple, I'm saying 89 degrees phase shift. And that gives a power factor of 0.017. So, there you go. Okay, so it's like 1 watt in, 13 watts out. So times 13. Maybe I'll get up to times 15. Maybe not, but so this is pretty good though. Alright, thanks for watching.